Okay, if you're seeing my screen, you see question B, part B. It says find the slope of the tangent line at the point minus 3, 3. Do you see that?
Yeah. Mm-hmm.
Okay, great. So assume you already did part A for a question. Part B is to take those values and plug them in for X and then in for Y wherever you see that.
Okay, so, I can do that.
Yeah. So now Y prime equals -1 minus 3 over -3 minus 3 times 3 squared. So lots of threes. And I like to put in parentheses when I substitute. I think that's helpful, especially with signs. So on the bottom here, it's -3 minus 3 squared is 9 times 3, so minus 27. So this is -4 over -30, which reduces to 2 over 15. So part B is always to put the numbers in back into the one you just got. Okay, now part C, and we can do that for this one here. Let me grab it here. So it says find the x coordinate of each point on the curve where the tangent line is horizontal. So again, we're looking at this one up here. So it's saying like where, keep moving this out of the way, where is this thing equal to 0? Where does y prime equal 0? That's what it means for it to be horizontal.
Okay, so then we set the
numerator, yep,
zero.
the top
Yeah.
equal to 0. So it's -1 minus y equal to 0. Solve for y. Now in the previous one we solved for y and it was in terms of x. So this one's still y equals -1. Okay. You could get a value. It could be y equals -x or y equals 1, but the key thing in here is to substitute it back into the original. So you take this. Okay, and actually this is going to be a bad example because it's not going to work out nicely, but you take that value and you put it, you take this y value and you put it back in.
Okay.
Problem is that this one's going to result in no solution, but that's just because of I didn't look through this very carefully and so on, because you get x minus x and then -1 cubed. But the point is, and that's what's most important here is to put, y equals whatever back into the original.
Okay.
All right. So would you like another example?
Wait, so that's the original function that was given, right?
No, this is a new one I came up with. We did the original one in the previous lesson.
Oh, okay.
So I can find one if you want that kind of works out better.
Okay.
I don't know if I can find one real quick. These are they get really complicated really fast. So I'm just struggling to find one here. Did you do any homework on this at any point?
I think one of the math excels was, I can see. Or maybe the derivative or any of these like that. Are these the ones where they give you a point like at x equals or no?
Yes.
Okay, so then the derivative thing worksheet that I sent, I think would have some.
Here, I found one here. This one actually, I think would be a good one for us to do because I can see the graph. It does work out nicely. Plus, it's got some of the stuff we've already been talking about here. So let's do part A, which is to find dy dx.
Okay. So x 3x squared plus 3y squared y prime equals 2y prime, right?
This is product rule.
Oh, yeah. Okay.
It's very important. Let's get this down.
2 times x y prime plus x, well, no, 1 y. Yes.
Yeah, so I mentioned this in the previous one. You might want to just remember this.
Right.
Yeah, for now, it will become more clear. So this is where you, it's I guess it's 4 things. It's like simplify-ish, move, factor, and then divide. So the simplify here really could mean a lot of things, but it's like distribute the 2 to both.
Okay. So 3x squared plus 3y squared y prime equals 2x. Okay.
Okay, and then move. So you move the y prime terms to the same side.
Okay, so 3x squared minus 2y equals 2xy prime minus 3y squared y prime.
Okay,
And then you do the,
now you factor.
yeah, so then 3x squared minus 2y equals y prime. Yep, 2x minus 3. And then divide the other side by 2x minus 3y squared. And yeah. And that's it, right?
Yep, that's it. That's it for part A. So now part B, let me find a point that's actually on the curve. Looks like 1, 1 is. So part B, for part B, we're going to evaluate it at 1, 1.
Okay, so 3 times 1 squared minus 2 times 1 over 2 times 1 minus 3 times 1 squared, which is just 3 minus 2 over 2 minus 3, negative, or 1 over negative 1, so negative 1. Yes.
Yep, that's right. So now part C, and we can cut through it. You need to set the numerator equal to 0 for part C. So you're going to set 3x squared minus 2y equal to 0. And you solve for y. You always solve for y.
Minus 2y equals 0. Squared. 2. Yep. The same thing.
Okay, great. Now this looks horrible, right? But this is what you substitute. Now you're not going to get one this complicated, but we're just going to do this for this. Substitute back into the original. So the original, you get that. Go grab it here. Here's the original. So this right here is going to go in for y and for y. So you get x cubed plus 3/2 x squared cubed equals 2x times 3/2 x squared, like that.
Okay.
This one has nice solutions ish, so just go with it for a moment. So it's x cubed plus 27 over 8 x to the 6th equals, okay, and then this becomes 3x cubed right? X to the 1, X squared, that gives you that.
So you just did three halves cubed, and
Yep.
then you multiply the X. Okay, got it.
Yep. Okay, so now we're going to subtract 3x cubed from both sides. I'm going to slightly rewrite this. So it's 27 over 8 x to the 6th minus 2x cubed equals 0.
Okay.
You factor out an x cubed. So you get 27 over 8 x squared minus 2 equals 0. Okay. Now we're going to ignore this because this is not the point of this problem. But you said each of these equal to 0.
Okay.
So this one equals 0 and x equals 0. So assume that's the only one. There's another one, but let's assume that's the only one. And then you put this back into the original.
Put the
This x cubed plus y cubed equals 2xy.
put both your solutions back in.
Yeah, now this one over here creates another one, but we're not going to deal with it unless you really want to. If you really can.
But like you would put both back, right?
Yes.
And then that's your what? Like
so it's 0 cubed plus y cubed equals 2 times 0 times y. This simplifies to y cubed equals 0, and then you solve for y. You're trying to get the ordered pair.
Oh, that gives you the ordered pair. Okay, gotcha.
I'm going to snip in this image because it'll give you a little more context. I guess I should have done that from the beginning. So it's like knowing where you're going to help with this. So the original problem was to figure out part C is to figure out where there's a horizontal tangent. And you can see there's one here at the origin at 0, 0. That's the one we found. And then there's one kind of right here.
Okay.
Which comes from this nonsense over here that we're not going to deal with. Unless you want to, but
no, it's fine.
But if we go back to the problem you were doing in class, like you set the numerator equal to 0. Okay, and let's maybe look at that one more time. Maybe that is the right way to do this here, to get to just come full circle and then like see how in your problem how it works. And then we'll move on to 4 and do a bunch of examples of that.
Okay.
So this is in your problem here. This is one you absolutely have to be able to do. You have to be able to take derivative, right? Power rule, product, power with y. Okay. So you've got your notes. I want you to get the derivative of this.
Okay.
I need to be perfect. You can do this. So let
right.
me know. Let me know when you're. Take a minute or two and see how that goes.
Oops. Paper. So. Okay.
All right. Do you want me to write the solution here, or do you want to tell me what would be best?
I can tell you. I think I
Okay.
got it. 2x minus x y prime plus y. Oh no. Yeah. Well, and then you distribute the, and then plus 2y plus equals 0. Oh, I forgot the y prime.
So definitely want to practice again before before tomorrow. That's another minus. Okay, so now I'm just gonna quickly get this. Oh, go ahead.
So anywhere there's a y, you just automatically add like a y prime to it?
You're always gonna have a y prime in that case.
Okay. Maybe that'll help me remember it.
Yeah. I tried to emphasize it earlier. It's like it's really awkward because the ones you're missing up are 2y and y squared. Okay, so dy of each of these. Let's just do them real quick. For y squared, it's 2y y prime.
Mhm.
For dy of 2y, it's 2y prime.
Okay.
And that's got to be like drilled in. Like, okay, I understand the difference of them.
Okay.
Okay, so over here on the left, what I did is I just went through it real quick with the simplification because we've already worked through it before. Part B is just putting the numbers in.
Okay.
X and Y. Okay, so you know how to do that. If you want to, you can here. It's part C that we're most interested in. That's probably where the most confusion will come.
Okay, so 3 minus 2 times negative 3, 2 times 3 minus negative 3, 3 plus 6, 3, 1. Yeah.
Yes. All right, so let's look at part C. Okay, and let's look at together. And you know, if there's anything that's unclear, let's get it dialed in right now. Find the so C is like the overall goal. Like C is like the last question on the SAT. Let's actually start here. What is the slope of a horizontal line?
Numerator equal to
So the slope is 0, and
Right.
you set the numerator equal to 0. Now this next part right here, write an equation for y in terms of x. We'll stop right there. It's kind of a leading thing. Like your instructor already knows that when you look at the numerator up here, that it's in terms of x, because it could be just a number. So that's where you say y minus 2x equals 0.
Okay.
And said write an equation for y in terms of x. That means to solve for y equals 2x. Now this last part, substitute it into the original equation. So what is the original equation? The original equation is x squared minus xy plus y squared equals 27. This right here, that's the substitute. There and there.
Okay. So
Just before we do anything further, like again, like you probably won't get the hint. So you have to know to set the numerator equal to 0, solve for y, and then substitute it back in.
and that equation came from,
This is the original.
that's the original. Okay. So then you substitute it back in. So then 2x, and then that's how you get your ordered pairs. So
Yeah, that's how you get x, and then you get
okay, so let me solve this. So that's 2x squared plus, and then you can combine those. Plus 2x squared 3x squared plus minus 3.
yeah, so x is plus or minus 3.
Oh,
So
and then you use the y. What was it? Y equals 2x.
right. Yeah, so you say if x equals positive 3, if x equals minus 3, what is my y?
So then it's 6 or negative 6. So
That's
then your
right.
points are 3, 6 and negative 3, negative 6.
Exactly.
Okay.
So we did some problems in geometry where it was like, find the distance from a line to a point, and they're like 5 or 6 steps. This is kind of like that problem where you have to be really comfortable with each step, and I think you can do it. Just if there's any questions, let me know, or we should move on to questions of number 4 type.
Can you give me just one more, like just finding the derivative?
Yes.
So I can get one.
Absolutely. X squared minus y squared plus xy equals 2y.
Okay, so 2x, or do you want to write it out and then I'll just check?
Yeah, let me write it out here. 2x minus 2y, that's power rule, then the y prime plus, this is product rule, so there's 2 terms. That's also should be part of it. X y prime plus y equals, this is, if you treat it like 2x, the derivative is 2 followed by a y prime.
Got it.
Great. Okay, so the rest of it is just algebra manipulation, solving a literal equation. I'd like to move on to 4.
Yeah, I just wanted to get that part down.
Okay, so to do 4, I'm going to remind you of some exponent rules. The first one is x to the a over b means the bth root of x to the a. So for example, if I say x to the 2/3 power, this means the cube root of x squared. And it's sometimes good to have a number like reminder of this. Like the letters are good, but you might not remember which order they go in. So basically the bottom number is the root. Okay. So that's one thing. The second thing is, if I tell you the square root of x plus y plus z, there are implied parentheses. So this is really x plus y plus z to the power of 1. And if there's nothing here, it's a 2.
Mhm.
So this becomes x plus y plus z to the 1/2 power.
Okay.
Do you follow that?
Yeah.
Okay, so now we're going to actually go to your problem, and we'll do several like this if needed.
So if it was like a cube root instead of a, oh,
Sure, then it's a 3 on the bottom. So,
Okay.
so the first thing is, and you've seen me do this in a lot of problems. It's like you always want to try to rewrite. There's for lack of a better word, deception in these problems where they're trying to get you to look at something that's not there. So this is 7 plus cosine 3x to the 4th root, to the 1 to the 4th root, and then
The
where
1/4.
yeah, and that's where I really want you to be able to get to without like having to write. I want you to be able to go right to here, but it's okay if you write this step, because when you see this, it's a power rule. Power rule is the first thing you do. Then it's a chain rule, because there's
So
stuff inside.
what did I ask? What's like the question say to do on this one?
Dy dx.
Okay. Using the chain rule.
It doesn't say, I mean, it just says dy dx.
Okay.
Okay. So really this problem should have been number 1.5 because it's much more like 1 than it is 3. So let's do the derivative.
Okay.
The derivative is power rule first, right? Power rule, keep the inside. So 1/4, 7 plus cosine 3x, 1/4 minus 1 is 3/4. So we've done the power rule.
Why'd you put -3/4?
1/4 minus 1.
Oh, okay.
1/4 minus 4/4 minus 3/4. Okay, now you're multiplying by the derivative of the inside. What is the derivative of a constant?
0.
0 plus, what's the derivative of cosine?
Negative sign.
Negative sign, keep the inside. Okay, what's the derivative of 3x?
3.
Now this 3 goes here because it's part of the derivative of cosine. That's why it's here. Now it's not part of the derivative of this thing right here.
Mhm.
So you can leave it like this. I think you might check with your instructor. Let's do another one.
That's the chain. That's the chain rule part right there. Right?
Yes, yes. So let's make it with just different numbers, same thing, and then I'll give you some variations on this.
Should you put the 3 in front of the sign?
It can go there. It's okay here as well.
Okay.
Okay. Here is your problem to try.
So let me get okay.
All right. I'll just write out the answer and you can check.
Okay.
So the answer is 1/5 parentheses -6 plus cosine 2x all to the power of -4/5 times the derivative of -6, which is 0, plus sine 2x times 2.
Cosine 2x.
And actually, I'm sorry, derivative of cosine is a minus sign. I'm sorry.
Yep. Got it.
All right, let's try a little wrinkle on this because, and there's lots of variations in this. Like, I don't know the depth you're getting in class, but there's so many different ways to make this problem, more challenging. Y equals the cube root of 7x minus sine 2x. So give this a try on your own, please.
Okay.
Then we'll work through it together if needed.
So Okay.
Would you like me to write down the derivative or work through it step by step? What would be most helpful for you?
Just write it down because I think I got it.
Okay, so it's really, power rule again. So 1/3 7x minus sine 2x to the minus 2/3 power. That's the power rule. The derivative of the inside function, it's now 7x. Derivative of 7x is 7 minus derivative of sine is cosine 2x, but then the derivative of 2x is 2.
Yep.
Great.
Got it. So the only difference was just the 7, right?
Yeah, and sine
7x.
sine versus cosine. I mean, you could there's so many things you can do here though, like to make these different. That's why it's not sure how many of the same to give you, but I think this is good.
Okay.
I see the calculus derivative droodle from the far side.
Oh yeah, that's my homework.
We could work on some of that if you would like.
Yeah, maybe we can do some of those.
All right, I'm gonna pull up 11 first because it's an implicit derivative, and that's something we've done a number of, but we got to make sure you can do that right. So this is number 11.
Okay.
So give this a try. You're doing the implicit derivative.
All right. So. Do you want me to distribute or just leave it?
Yeah, why don't you distribute, and I'll write out the answer here.
Two xy prime plus 2y. Yep.
Great. So we're not done though. Here we actually need to solve for y prime and put the numbers in. So actually I take that back. So some students, they put the numbers in at this step, which might make sense actually, but usually they ask you to find dy dx, then put the numbers in. Maybe that was unnecessary, but you could say, okay, 1 plus 2 times 1 y prime plus 2 times 1 minus 2 times 1 y prime.
So what we've been doing is moving it.
Yeah. Which you probably should do. I guess sometimes I think of things that I shouldn't say because they're shortcuts in short, like.
Okay, so it's 2xy prime minus 2y prime equals negative 2y. Wait, no, that was so wrong. No, it was right. I did that right.
Yep. And there's a couple ways to do it because you can actually move y primes,
Yeah, okay. So then I take the y prime out. Okay, I did this right. And then times 2x minus 2y. Y, and then we divide by 2x is 2y. And then from there, plug in what was the points?
1 1.
1 1. Okay, so then.
And this is actually good that we did this because this is an unusual case. So when you divide by 0, that's impossible. It's impossible.
Negative 1 minus 2. Okay.
And that means it's non-existent. What that actually corresponds to is a vertical tangent. which you may or may not cover in your class.
Vertical tangent at the point 1, 1.
Yes, and it's more generally, it's where the bottom is equal to 0. So the horizontal tangent is where the numerator equals 0, and the vertical tangent is where the denominator equals 0.
There's no horizontal tangent, right? It's just vertical.
Right. So from previous classes, you know that like x squared plus y squared equals 1 is a circle. And I'm going to just draw it a little bigger than usual. Do you see that it has a vertical tangent there and there?
Yeah.
And a horizontal one there and there?
Mm-hmm.
And that's how this happens. I mean, that's the, so.
Because there's no like x or anything in the numerator. Oh, I guess.
Well, you set the numerator equal to 0, and it ends up being at 0, and the denominator equals 0 here. So I don't think that'll be covered based on what we saw, but it was worth looking at.
So would you just say that it's non-existent?
Yeah.
Okay.
And I wrote that down here. It looks like it's T non-existent. So let's actually do, believe it or not, 14.
Wait, why T?
That's just the letter on the right side.
Oh, gotcha.
Okay. So I'm just trying to help you, giving you a little head start on it. So this is what I just said. This is another implicit derivative. It's a circle. So go ahead and give this one a try, please. X squared plus y squared equals 100.
X plus 2x plus 2y, y prime equals 0.
Very good. So I want you to solve for y prime and simplify.
Okay. Negative x over y equals y prime.
Yes. Okay, so if you were to set the numerator equal to 0, and it's there's not much to do here. Negative x equals 0, which means that x equals 0.
What is that for?
That's for that part C. Like, okay, it's not for your homework. Sorry, your homework ends there. Your homework is there. It's let's see, it's letter
H.
Yeah. Yes.
But what, like for the C, what was the question asking again?
It was asked, let me snip it in here again. So you're trying to find the x coordinate where it's horizontal, but really it comes from what is the slope of a horizontal line? It's when the slope equals 0, which is the derivative, when the derivative equals 0. So this is your derivative, the y prime.
Mm-hmm.
That's why you set the numerator equal to 0.
Oh, right. Okay, so that's where you're trying to find the points. Okay.
Yeah. So now that we have that.
So now you plug it back in. So negative 0 over y. So it has to be.
So you put this 0 back into the original, which was x squared plus y squared equals 100.
Okay. Y squared equals 100. So it's 0 plus y squared equals 100. So y squared equals 100. That's just the square root, so 10,
Plus or minus 10, because remember, it's a circle.
right?
So it's got two spots. It's got this one up here and one down here. So
So
that's the 0.
comma 10, and then 0 and negative 10. Okay. Perfect.
Okay, so why don't you look over that worksheet, because we did the two implicit derivatives, and see if there's others that you want us to go over.
Let me see the just look quickly here at the PowerPoint.
Yeah, or anything in the PowerPoint.
Let me see.
Wow, they're hitting you early with AP signups.
Oh yeah, I already did it. They were due on Friday.
That's incredible.
Yeah. And they're like $96 each, which is kind of crazy. But
Yeah. Well, it'll be the cheapest college credits you get.
yeah, exactly.
When you
If
get
you
your
credit.
well, you're gonna do well. It's you're doing the right things to get a good score on this.
Maybe we could just do some more of the chain rule stuff from the PowerPoints. I don't know. Maybe like
Was that 4.1 or 4.2?
on like 4.1 day 2, there's like find the equation of the tangent line
Okay.
to the curve. I don't know what slide it is. It's like, oh, I can see it. Slide 9, I want to say.
That's projectile motion. Maybe I'm looking at
Oh, the one before it then.
yes. Well, I see a chain rule to find the derivatives of the following, and then let's
I mean, we could do any of those. I just
okay, yeah, this is a good one for us to do, I think.
or just
many-
some more like simple derivative. I mean, chain rules ones too. I don't care, whichever.
How many APs are you taking this year?
4, yeah, 4.
Right. Okay. So I'm going to use some colors here because I want to make it clear, like this is the outside and then this is your inside.
Okay.
So you do that second. Okay. But then there's a third one here when you take the derivative of sine 2t, that ends up being your 3. So from your and like I can't do this with you, but because it's all virtual, but if you could cover up the 5 minus sine t, and I said, what's the derivative of tangent? That's what you got to be really fast at. So look at your sheet if you need, what is the derivative of tangent?
That was secant squared x.
So you can square it. So it's secant squared of whatever's inside, 5 minus sine 2t. And again, if you could see my screen, my hand, I'm covering up now tangent because we actually don't care about tangent anymore. We're just looking at 5 minus sine 2t. Like your eyes are focusing on this. What is the derivative of 5 minus sine 2t? Well, it's two things. It's what's the derivative of 5?
0.
0. Minus what's the derivative of sine?
Cosine.
Cosine. Keep the inside. What's the derivative
And
of
then
2t?
it's the derivative of 2t, so 2.
Yes. All right, so let me give you one like this to try.
And you just leave it like that.
Yeah, I don't think you need to spend a lot of time thinking about that.
Okay.
So let's do tangent cosine 3x minus 5.
Okay. So we got secant. Three x 5.
So I'm just going to start writing.
Check.
Derivative of cosine is minus sine. Keep the inside. And then you have to take the derivative of this with it. So that's why there's a 3 there minus.
Okay, so I
minus-
just didn't know if I should put the -0.
You don't like I don't if I so like the first time I show you, I want you to do that, but then eventually I don't want you to put that.
Okay, I got everything. I put the -0.
Yeah.
I just didn't know if I was supposed to.
Like it definitely won't be on the AP like this ever. And your calculus 2 instructor won't like it, but for now it's fine.
So then you would just stop it at the 3.
Yeah, but I mean, like, but if this were in a textbook, you would see the following most likely: -3 sine 3x secant squared cosine 3x minus 5. It would be the negative, the constant would be out in front,
Oh,
you know, or
But
it'd be
like-
secant.
but for the purposes, like you would just leave it as
Yes,
the one above. Okay.
yes. All right. Let me make one more up here, and then we'll just do it real quick. It's a variation on one of the other ones in your. Well, actually, this is what your instructor gave you for. Actually, let's do it to the 1/3 power.
Okay. Bring the 1/3 out in front.
That's right.
And then it's 1 plus cosine 7x.
Okay, and then you keep going. What's the derivative of 1?
0.
0. So I wouldn't even write it. I won't this time. Derivative of cosine is minus sine.
Sine 7x times 7.
And you're done.
Oh, okay. Awesome.
All right. Thanks so much for scheduling. I hope your quiz goes well. And
Thank you.
I'll see you next time. Yeah.
Can you send those notes out?
Yeah, what I'll do is I'll send the notes out like within 2 minutes. The videos are taking longer to upload.
Oh,
So
yeah. Okay, perfect.
I'll send those out right now.
Okay, thank you.
You're welcome. Bye now.
Bye.